So 5.7, finally we've come to equations. And so again, that's what algebra is all about. Can you solve an equation? Can you set up something you don't know, put it into an algebraic form, and then solve it and done? That's what we want to do here. And we want to take a look at quadratic equations. First of all, quadratic equation, what does that really mean in the first place? Is that somewhere along the line you have an x squared somewhere in there. Once you have an x squared, now you're talking about no linear functions anymore. Now you're talking about quadratic functions. As I mentioned earlier, the whole point of factoring is to take you down from x squared down to just x by itself. You want to go from quadratic back down to linear forms. And if you can get there, then you're good to go. Then we're in chapter 2. We're solving linear equations here. Okay, then something called standard form. Standard form is the degree on the x, it goes from highest to lowest. So you go from x squared, then down to x, then down to just a constant. So there's that. Cool. So solving equations here. God, how many problems do we have? We have six problems here. We'll just sort of take one at a time here, and then we're going to get into word problems 5.8. We'll go from there here. Okay, so before we get going, there's one little property they're going to think about, and once I say it, I think it's going to make sense here. It's called the zero factor property. It just says this. It says if you have two numbers, I don't care what they are, a times b, if you multiply them together and the result is a 0, what do you know? You know that at least one of these numbers is 0, right? Because either the a is the 0, and a times any number is 0, or the b is 0, or it could be that both of them. So this little or statement, that's what it says or. Or just means it's either this one or this one. It could be both. That's called the inclusive or, which means it allows for both of them to happen. Okay, so let's just kind of think about this here just for a little bit and make it a little more abstract in our minds here. So if I have a number like this, or an equation like this, 3x is equal to 0. Without dividing by 3, don't want you to do that, what does x have to be?
0.
Yeah, there's no other way around it, nothing to do with there, x is equal to 0, that's it. Okay, how about this? How about if I have an x and a y? What do we know now?
X more y.
Got it. So we say x is equal to 0 or y is equal to 0. Good there? Next, make it a little bit the next level here before we get to the practice problems. X times x plus 2 equals 0. What do we know here?
X.
I got the x equals 0 or
X plus 2 equals.
perfect, you got it. It's the first thing that multiplies, or the first factor. X is equal to 0 or the x plus 2 is the one that equals 0. Okay, so if we think about these here, notice this one's already solved, right? It can't work anymore. This one's solved, this one's solved, this one's solved. Hey, that's not solved. So there's an extra little step here. Subtract 2 from both sides, will that work?
Mm-hmm.
So then for this problem here, the answer to this problem is that if x is equal to 0, this answers this problem. This is a solution to this problem. If x is equal to -2, that is also going to be a solution to this problem. Okay, we found actually 2 answers to one single equation. Okay, good there. Don't need to go any further with that. Okay, maybe I should. Let's go. So if I were to plug in 0 back into this, it'd be 0. 0 plus 2 is equal to 0. Is that true?
Yes.
Absolutely, because if you simplify this, it becomes 2. And 0 times 2 is still 0. That checks out. If you plug in a -2, let's just do it this way here. -2 comes in for the x, -2 comes in for the x over there, and the question is that still true? Absolutely, because the stuff inside the parenthesis will become 0. -2 plus 2 is still 0. They're opposites. And then you get this, which is done. Okay, we good? Alright, now let's go to our problem here. Okay. Let's go to an example problem then. So x squared plus 5x plus 6 equals 0. Why did we learn factoring in the first place? We learned factoring so we can do that right there. We can factor that down. Two numbers multiply 6, add to 5, 2 and 3. And then we have the zero product property says, I'm going to split this off two different pieces. So there's my little or. It's either the x plus 2 is equal to 0, the x plus 3 is equal to 0. Solve each of those. Boom, boom. Okay, now I got to tell you a little thing here. Why is there an or here? I know because of the multiplication. But when we get to 5.8, we're going to find out that sometimes we can't use those as answers as well. So if you plug it back in, yeah, it's going to work, because if you did the factoring process correct, that's going to work. -3, plug back in, it's going to work. As far as word problems are concerned, kind of like, you know, let's say x represents time, right? And let's say x is equal to -2 and x is equal to +3. Obviously what we're going to do is we're going to get rid of the -2, right? Because time can't be negative. And that's also that little or statement. Sometimes only one of them is going to be the real answer. Okay, good there? Let's jump to 1. So all yours, can you factor? Before you can factor, just one little tidbit, you got to set it equal to 0. Because factoring occurs after you have set your polynomial to 0. Alright, hopefully we got it here. Nope, some people still guessing and checking. So wait just a little longer here. Alright, I'm going to go for it here. So again, 2x squared, that's a nice one, because there's only one way to get a 2x squared. It's 2x times x. 15, yeah, I got some real quick here. 5 or 3, 15 or 1, right? I probably choose the 5 and the 3, start working that out. And I think we got it already here, is that right? Especially when you think about 2 and 3 would make 6, and now you have a difference of 5. The difference between 5 and 6 is 1, so that you can go like, hey, I think I got this. So there's my -6x plus 5x makes a -x. Cool. I'm not going to work that much with you on the factoring part because we did that before. This is just more of concentrating on simplifying the solution here. Okay, so zero factor property says 2x plus 5 equals 0, or x minus 3 equals 0. And let's solve each of those. So subtract 5 from both sides. How about a -5 divided by 2? And how about a -5/2? Other side. Adding. Perfect. Cool. Okay. We're done. Factored. Zero factor property. Solve each step. And we are done. So the way the back of the book says it is x is equal to -5/2, comma 3. Both are answers. Do we need to check our answer? No. We don't have to check our answer as long as you know you did the steps correctly here. Alright, let's go for it. Number 2. Boom. Okay, should I give you any hints here? Okay, maybe. Something about special form, special form. Alright, hopefully you factored it down into a 9a plus 2, 9a minus 2. Awesome. Zero factor property, set each of those equal to 0. Perfect, negative 2 over 9. You got it. And so in this case, the difference of two squares will actually also give you opposites for your answers as well. So negative 2/9, positive 2/9. Okay, and as stated before, remember what we have to do before we can factor, we have to set it equal to 0 first. Then we can start factoring things. So number 3 is going to test that for us. Alright, number 3. So what should we do first? Oof, not factoring yet.
6 each of them equals to 0.
Divide the 3.
Nope, nope, and nope.
They got an X.
Nope. Let's set the whole thing equal to 0. How should we do that?
Bring.
Do
Add
A
the
squared
27.
equals to 0.
Not add 27?
Subtract.
Subtract 27. Here we go. There we go. So I got to bring everything over. Kind of didn't matter which way you wanted it to go. You could actually subtract the 3x squared, but why do that when you're going to have it in standard form already? And you're going to have the number in front of x squared to be a positive. So perfect. 3x squared minus 27x is equal to 0. Okay, and then maybe let's do these together here as we go. All right, what's the next step?
Factor.
Yep, and how much?
3x.
3x. Good. 3x goes out. Leftovers?
X minus 9.
Okay, so notice when we did step 1 of factoring, we did the greatest common factor rule. When we did that, we have no more x squareds anywhere. That's cool, because then we're done with factoring. If this has still had an x squared minus 9, we would still be factoring, right? Well, you know you're for sure done with factoring when you don't have any x squareds anywhere. So 0 factor rule. The 3x goes to a 0, and the x minus 9 goes to a 0.
So the goal is to not have anything squared.
The question is the goal not to have anything squared? These will work out that way, yes. Eventually you'll learn a different technique to figure out how to reduce it even more, but that's sort of midway through Math 63. Yeah, it's going to work out nicely. Alright, so hopefully you guys got x equals 0 and x equals 9. Perfect, x equals 0, 9. Again, the book always puts it, I think, in like numerical order, so 0 would go first before the 9, but it doesn't matter. So you can put 9 comma 0 as long as you have both numbers there. Okay, and number 4. Hey, this is already in factored form. That's cool. What's not so cool is it's not equal to 0. Alright, so in this case, what we got to do, we got to multiply everything out and then set equal to 0 and then start factoring. So x times 2x, 2x squared, x times a negative 1 makes minus x equal to 10, and what should we do next?
Subtract the x. Subtract the 10.
Yep, perfect. Subtract the 10 over. And now let's start factoring, and this one actually I'll let you finish off by yourself because it'll give you some practice with factoring. Alright, hopefully you did the factoring here. So again, the only way to get a 2x squared is 2x times x, and then you gotta think about the 10. So 5 and 2 maybe, 10 and 1. I'm thinking 5 and 2, and the reason why I'm thinking 5 and 2 because I need a negative 1 here. I'm thinking because 2 times 2 is 4. So now I got a difference of 1 between the 4 and the 5. So that means I need the 4 over here. That means I need the 5 over here. So how about a plus 2? That would make the 4x here happen. Since I need a negative 1 here, that means the minus sign has to go with the 5. Okay, Does that kind of help out, sort of mentally see how that's done? All right, and set equal to 0. Each of those here, 0 factored property, and solve. How about adding 5 to both sides, dividing by 2 to both sides, 5 halves. The other one subtracting 2 from both sides. And we get ourselves 5 halves, comma, negative 2. All right, number 5. Whew, okay. Okay, set equal to 0, that's kind of nice. But I got this x minus 1 to the second power. If you know the special form, you can FOIL this out, right? If you don't know the special form, then you can just FOIL. So we have to multiply this guy out first. So if you need to, go off to the side, just put x minus 1 times another x minus 1 and see what you get from that. Yep, or x squared minus 2x plus 1. If you know the form, right? Square the first term, put the minus sign, double the products of the terms, and then square the last term. So let you guys catch up here on that one. Everybody good with that? Because some people are staring at the board here. Everybody good? Multiplying that middle term out. All right, so I still have the x squared that's in front right here. And then I'm going to bring in what I multiplied out over here. So this is plus an x squared minus 2x plus 1, and I still have the minus 25 over here. So I have multiplied this out. All right, collecting like terms, that's kind of nice, I guess. So the x squared and x squared makes 2x squared. Just a minus 2x over here. And let's see, what is this? 1 and negative 25? Negative 24 is good, equal to 0. All right. And to give you a little hint here, something like greatest common factor. 2 is the greatest common factor. Not an x though, right? Because this one does not have x. Just 2. 2 goes out. Leftovers?
X squared.
X squared?
X.
Minus x?
Minus 12.
Minus 12. Good. Okay. All right, can we factor the stuff that's inside the parentheses? Negative 3 and 4, I don't think so. Negative 4 and 3, I think I'll go with that, yeah, because of the little negative 1 in the middle that needs to happen. Okay, this is new stuff. We haven't got to this yet before. The reason is because this little 2 on the outside. And what the book does, kind of funny, it just sort of drops the 2. Like, no, it's gone. So let's talk about it, why it's gone. So as the 0 factored property says, if I have this guy multiplying times this guy to give you 0, that means this guy's either a 0 or the middle term is a 0 or the last term is a 0. But good? Just breaking up. You could have 3 terms, you could have 4 terms, 5 terms. But all those will be equal to 0. So why does the 2 disappear? Because we know that 2 does not equal 0. And so that one sort of gives us a no solution. So if you have a coefficient that's just a integer value, you can really just drop it. It wouldn't matter. The other ones, yes. The other ones, how about a x equals 4, and how about x equals negative 3? Okay, so x equals 4 and negative 3. Alright, and the last one. Let's go with that. Need to go back? Anybody? Go back to number 5? Alright, this one, the hint is greatest common factor. Something about greatest common factor.
Yes.
Mm-hmm. Alright, factoring out the x out leaves us with 6x squared minus x minus 1. Remember, if you take out the whole entire term, you still have a little 1 there left over. Alright, next.
So that's
Yep, let's see, it's so 6x squared, again, it's this little guess and check now. Either 6x times x or 3x times 2x. A little hint, maybe, is most typically if you have a choice between like 6 and a 1, 2 and a 3, most likely it's going to be the 2 and the 3. Like with 15. 15, if I had a choice between 15 and 1 or 5 and 3, I'd probably choose the 5 and the 3 and try those first before I exhaust those. So 3x times 2x. Now we've got to play with the negative 1 somehow. And that's not too bad, huh? Because we need a positive 1 here to give you a 2x. We need a negative 1 to give you a negative 3x. Therefore, the little negative is going to be a little higher. Okay, but if we have a variable, right, as a greatest common factor, notice in this case, yeah, this one you do have to factor out to give you 0, or 3x plus 1 is equal to 0, or 2x minus 1 is equal to 0. Cool. All right, so this one, what do you guys say? X equals 0. That's already solved. Is that right? That's cool. Let me solve that. So how about subtract 1? How about divide by 3? So negative 1/3. Over here, how about adding 1? How about divide by 2? So x is equal to 0, negative 1/3, and 1 positive 1/2 in any order whatsoever, as long as you have, ooh, whoa. In this case, we actually have 3 answers this time. 3 answers that work for this particular problem. And so maybe just to show you something here, 0, 0 would work, wouldn't it? Because if you plug in a 0 to all 3 terms, wouldn't that just be 0? Right, so then it also says negative 1/3 would also work by the time you square and FOIL things out and cube things, and then also 1/2 would work as well. Alright, so that is the end of 5.7.